In the last video, we ended by discussing what a term is, and we said that a term was a collection of coefficients and variables separated by multiplication. A polynomial is a collection of terms separated by addition and subtraction. And we have several different types of polynomials. We have monomials, binomials, trinomials, and general polynomials. Now I do want to add one extra piece to this definition. When we're talking about a polynomial and its collection of terms, we must also recognize that the terms have an exponent that is a positive integer, or in other words, a whole number. So you should add this extra comment to your notebook as well. Exponents of terms must be a whole number. And you'll remember whole numbers start at 0 and then they go up from there. So 0, 1, 2, 3, 4, so on. As long as it doesn't have a decimal or a fraction to it, we'll consider that a whole number. So a polynomial, based on all of these definitions, might look something like this. Let's say I have a 3x cubed plus 2x squared plus 7x plus 2. This would be considered a polynomial. We have four terms separated by all addition signs. This first term has a coefficient of 3, a variable of x, and an exponent of 3. We have a coefficient, variable, and exponent for every additional piece. Now down here you might recognize that there isn't an exponent written, but you should remember that we can assume that there is an exponent here. It's just an exponent of 1. So again, we have 3 pieces to this term. On this last number, however, you'll see that we only have a number written, only a coefficient, and there doesn't seem to be a variable or an exponent listed here. We traditionally don't write this, but you can imagine that there is a letter x behind here as long as it has an exponent of 0. Because, again, you should remember that x to the 0 power, anything raised to the 0 power, is 1. And since x to the 0 power is 1, then this problem here is really just the same as 2 times 1. And well, what's 2 times 1? That's just 2 by itself. So again, even though the number, this coefficient, is written alone here, technically speaking, we could have introduced the variable and the exponent 0, and that would also make the equation or the expression equivalent here. Polynomials must be created with terms that are separated by addition and or subtraction. If I clean this out just a little bit, let me show you an example of a monomial. That's a monomial. It is a single term polynomial. The only term here is the 3x to the 6th power. Then a binomial should have 2 terms, so let's call that 2x to the 8th minus, I don't know, 3x to the 3rd power again. This would be called a binomial because it has 2 terms, 1, 2. A trinomial then should have 3 terms. Let's call this 4x to the 7th plus 3x squared minus 2x. This polynomial has 3 terms, therefore we would call it a trinomial. So monomial, binomial, and trinomial. If we ever encounter a polynomial with 4 or more terms, we generally don't give it a special name beyond 3, so we would simply call this a polynomial. And in this case, I would say it's a polynomial with 4 terms. If it had more than that, I might say something like a polynomial with 5 terms or 6 terms, or whatever's appropriate for the case. In the next video, we'll talk a little bit about adding and subtracting to combine like terms, as well as how to handle other operations with polynomials.